integral right here is a indefinite integral, as you can see here, and it's basically integrating 2x plus 1 over x squared plus x dx. And it may look fairly simple, but there are a few steps that go behind it here. The first thing is pretty easy. I want to simplify this as much as possible. I want to simplify it. So let's do that. When we simplify this, we can basically write this as the integral. Actually, let's just simplify this first. So if I have 2x plus 1 over x squared plus x, I can factor this, and it would basically become 2x plus 1 over x plus 1. So it would basically be 2x over x plus 1 plus 1 over x plus 1. Correct. Now we can basically cancel this thing out here, and we basically get 2 over x plus 1, which is pretty fair in all parts. So let's integrate that first. I'd like to get this little easy one out of the way here. So when we integrate this, according to our little law over here that we have, according to a rule where the integral of 1 over x dx is going to be natural log of x mod x plus c, the integral of 2 over x plus 1 is basically going to be equal to 2 natural log of x plus 1. All right, that should be pretty clear from this rule over here. Okay. All right. Now, next thing we have to focus on is this over here. We have our 1 over x bracket x plus 1. Now, regarding that, there's kind of a little problem for us here. We have to use partial fraction decomposition to split this into, if I may say, simpler fractions. And how can we do that? So let me just scroll down here. Partial fraction decomposition. All right, so let's do this. So here we've got 1 over, we have to integrate, we have basically 1 over x plus 1. Now, we can rewrite this like so. We can basically have, in terms of a and b, you would have a over some value of x, right? Plus b over some value of x plus 1. Right? So we're basically trying to split it into basically simpler fractions, right? But you have to represent it as a sum, if I may say so, right? So basically what we're trying to do is represent this as 2 simpler fractions, but with the same sum. Okay, so what we basically want is we want the same denominator, so that's fairly simple. We know how to do that. So we would basically get a over, it would be it would be x plus 1, and then you would have x plus 1 at the bottom. And then this would be plus b x over x plus 1. Correct? Now what we basically need to do is basically put these two together to get our new sum here. So let's do that. Since we have the same denominator, we can add it. And so our sum becomes a x plus 1. You can just put your bx here like so, and then you'd have x plus x plus 1. Okay? Now we need to set up the equation to solve for our a and b. So I'm going to do that in this box over here. Okay, this little line will do for now. So let's do this. So we're going to have, on our left-hand side of our equation, we're going to have a x plus 1, all right, plus b x, right? The same thing we have here, x plus 1, right? And on our right-hand side, we're going to have this one right here, our original. I'm going to circle it. That one right there, our original. All right, so let's put it in. You're going to have 1 over x plus 1. All right, now, since our denominators are the same, right, you can see here, all we have to do is focus on our numerators. So we're just going to have a of x plus 1 plus bx is going to equal to 1. Right? Now we can expand the left-hand side, which is going to be ax plus ax plus a, right? And so we can state this, that our ax is going to basically be equal to ax plus a plus bx. Correct? We just expanded it. That's all we did. And now if we do some simple factoring here, if we think about it, we factor this and this in, we basically understand we'll get this. Our a plus b, and then we get for x outside, right? Plus a is equal to 1. Now we just solve for our a and b. Now from our x terms, right? From our x terms, we can figure out that a plus b is equal to 0. That's true. And from our constant terms, we can basically figure out that a is equal to 1. I'm going to C for constant. But this is basically what we can figure out from here. So if we know these two are true and valid in fact, then we can state this. New page here. Since we know that our a value is equal to 1 and that a plus b is equal to 0, right? And we know that our a is 1, then 1 plus our value of b is going to be equal to 0. Then, therefore, our b is going to be equal to -1, right? We isolate for b. Now we can substitute our a and our b back into our original equation that we have, correct? So, basically, we have 1 over, remember, x minus 1 over x minus 1. And this is now our updated equation. I'm just going to put it right here. Our new equation. Now, all we're going to have to do is now we can just take the integral of this, and we can integrate this, and then we take, since we already have the integral that we did here, this one, we add those together, and we should get our final answer. So let's do that. So, let's do it. What we're going to be basically doing is we're going to take the integral. So the integral of 1 over x minus 1 over x minus 1 is basically going to be equal to, remember, this is going to be the natural log of x, natural log of modulus x actually, minus the natural log of x plus 1 and plus c. Now I potentially forgot something. You guys would have noticed this is my plus c over here. So yeah, now all we do is just put all of these together, which therefore our final integral, the integral of, actually let me just get the actual question up here, which is this. Take an integral of that, so we're going to grab that and just bring it down here. This is going to be equal to, all right, so the final part of this problem is to actually simplify it, so let's do that. Remember, originally we have 2 natural log of x and 2 natural log of x plus 1 plus c, and this right here, you can actually simplify it since we're subtracting a natural log of x plus 1, And all that's going to be left for us is just a natural log of x plus 1. So we're just going to be having the natural log of x plus the natural log of x plus 1 plus c, and this should be our final answer in this case. That's all. This was quite a bit of a tricky integral, especially for me, because I'm not really good at partial fraction decomposition. But yeah, other than that, I feel like this was a pretty straightforward one. And yeah.